Good morning, dear colleagues. Thank you to be on time to start these new sessions. These sessions will be dedicated to international remote sensing satellite, and we will present you different updates from the main satellite providers from USA, from Canada, Germany, from Airbus. And of course, this session will complete the previous session, which was dedicated to our colleagues from Russian satellite provider. I will invite Ilya Yudin, who is, of course, well known from most of you. Ilya is now sales manager for Russia, CIS, all Russian-speaking country, for DigitalGlobe, which is, as you know, the world leader company for very high-resolution satellite. The floor is yours. Thank you.
Thank you, Bruno. Добрый день, уважаемые.
Good morning, dear colleagues. First of all, I would like to use this opportunity to thank on behalf of DigitalGlobe all the participants and all the organizers of this very interesting conference. Thank you very much for selecting this place. This is indeed a magical place, and it will be etched in all our minds, and I would like to start my presentation. Now, my presentation perhaps is not as scientifically intensive as it should be, despite the fact that it is a scientific and technical conference. And yet, in my presentation, I will still attempt to tell you about a new paradigm of communication with our partners and clients. When I speak about paradigm, I mean the relations of other companies with DigitalGlobe, and I'll try to dissuade the false myths that DigitalGlobe is a very inflexible or unnegotiable provider of data. And I will speak about new opportunities too, of course. To start with, I will tell you that we live in a very interesting world. Our environment is changing so fast. We ourselves are observing and witnessing some of the events that never been here before, starting from wars and ending with some migration crises. Who and how can assess these new developments? In what way can we objectively evaluate what is going on in the planet? So for such new challenges, we have also new technological approaches that us, DigitalGlobe, as an operator of high-resolution remote sensing data, can provide. Here, you can see some of the statistical data. You can see that from the year 2000, 2012, we had a huge number of events which, one way or another, affected almost 3 billion people on Earth. The impact from the world disasters is increasing by 5-7% every year, and the number of people killed as a result of various such catastrophes and disasters is also growing. Here you can see some of the statistics. It's almost 11,000 people, about $106 billion equivalent, and each year these numbers are growing. DigitalGlobe traditionally is regarded as a company who is an operator of satellites, which is true, but it's not all of it. Satellites is only one part of our big company. Indeed, DigitalGlobe is a global leader in remote sensing market, and you know that we already have 30-centimeter resolution data. And this is a super high resolution and great coverage, which is updated intensely. And the archive, which is already about 100 petabyte, is in line with the total archive of Facebook. So the content of Facebook and content of DG are growing at the same rate. What are the main opportunities that I would like to overview here? First of all, it's the satellite constellations. I have some new things to tell you about here. Surface resolution, or spatial resolution, spectral band stereo and 3D mapping archive, and the last but not the least, something which should, I believe, change the interaction, communication between ourselves and the partners is geo big data. It is marked here by bold type, geospatial big data, which means big data of remote sensing. This is what must eventually put together all the above mentioned technical capacities of our satellites. Now a few words about the actual constellations. They are quite familiar to you, I think, but this constellation this year have been drastically reconfigured. We have discarded two satellites, Iconos and QuickBird. They've been working successful until the last moment in time, but they've been released because the fuel was exhausted, and they changed their orbit, and they're out of the constellation. But they left behind a huge archive, which is available for everyone. Now on orbit, still on orbit, we have Worldview I1, and it is moving a bit, and its orbit is changing to make sure that the time of local time of imaging would not be like in all satellites, like 10:30, 11:30, but something like 1:30 p.m. And the GeoEye 1, Worldview 1, Worldview 3, all of them are working in the standard mode. So we have a full satellites which are fully functional, and by summer, although in autumn next year, we are going to launch Worldview 4. What can be delivered by this satellite constellation? First of all, new opportunities on remote sensing with super high resolution, 30, 40 centimeter resolution. And this spatial resolution is not limited to these numbers only. In fact, it can be increased up to 50 meters, of course. And the products based on high spatial resolution are produced quite easily. It is an automatic process. We have 30 centimeter, we have 40, 50, 70, 1 meter, meter and a half, 2.5, 5, 10, 15, and 50 even meter resolution. Depending on the needs of the customer, we are prepared and are doing and will keep doing new products, and will remain flexible. Maybe somebody needs a project less expensive, than we can submit 70 centimeter resolution, which is quite with very competitive price, and this helps us adjust to the needs of the customer. And naturally, with the use of the whole constellation, we can in one day acquire data for about 4 million square kilometers. This constellation is used very intensely, and we have already accumulated a lot of data. And this data can be used in all sorts of industries, including ethnography, disaster monitoring, or infrastructure monitoring. I believe that you know it better than I do. I'm not going to dwell longer on this. I just want to tell you more about what unites all these new opportunities. It will be united by geo big data. That's what I'm going to talk about now. What else do we have to offer? Worldview 3. Its sensors can see in mid-infrared band, 1.2 nanometers We have 8 bands there in total. They're quite narrow. They're correlated with Aster bands. I will show it later. I'd like to note here that not only the satellites are technological advantage, or the number of ground stations, and their number has been increased, which increased the productivity of the whole constellation. The installation of one single additional ground station is comparable to a launch of a new satellite. So the more ground stations we have, the more computing power we have, and we can get more information from our satellites. We have a total of 12 ground stations now all over the world. Now, I can note that all our satellites are known for high quality of data. They provide data with the highest possible quality of data, which is the main competitive advantage that we have to offer. The quality is something that we invest in the most. We have a program called AF3C. It describes one way or another the way we see the data. First of all, it's the top quality, as I mentioned, then global, in global measurement, of course, and then acquisition of data. For different areas very quickly and on a timely manner. The completeness of data, which includes also completeness means such parameters as spatial resolution and consistency of data. One of the new innovations which will be made available as of January next year is the automatic building of compensated or atmosphere compensated data. All the archive data will be transformable, free of charge actually. It's an option for the customers to compensate atmospheric distortions. And based on this archive, we're going to build maps, not only the actual pictures, but also 3D DSMs. We can get them from different spectral bands. So these are the examples. 30 centimeter resolution. Naturally, 30 centimeter helps us see more details. The smaller the pixel, more information can we get, and people can globally view it with this spatial resolution. Any point on Earth. 50 centimeter, of course, is our main product. It enjoys the highest level of demand. Perhaps it's not as informative as 30 centimeter resolution, but still, it contains plenty of information. Another example of data, 30 centimeter resolution. Here you can see the astounding detail of infrastructure of oil refinery. And the specialists working in this field can acquire the data, and in fact they're quite satisfied with that, because sometimes to get such an objective data for remote areas is quite a tough job, but satellites can provide this opportunity now. You can even count here each tree or make high precision topographic plans. Here we can see an example of when you can see shadows of cast by people on this image. A number of other examples. Now about the precision or accuracy of data. It's difficult, controversial issue, but globally speaking, 5 meter is something that we can guarantee without the use of any additional points. Moving on, spectral resolution. Here you can see the location of bands on the axis for electromagnetic spectrum. We know that our eyes can see only within a narrow band, but the satellite can see in a broader band, and application is very broad for oil, gas, geology, agriculture, bathymetria, and monitoring of disasters and change detection wherever we need information. And on this diagram, I'd like to note that here we have bands from WorldView 3, which is called superspectral, and it has 8 bands on the visible infrared band and another 8 bands also infrared spectrum, and 12 bands for atmospheric compensation. All other operators of satellite systems can offer only 4 bands out of the visible and infrared spectrum. So these are the examples of how in the mid-infrared band the satellite sees our surface. This particular example is the visible band. We see the smoke from the fire, and here you can see the image acquired in the mid-infrared band. And you can see that it can see through the smoke. It is reflected from the Earth and goes back into the lens of the satellite. Stereo, I must mention stereo here. This constellation can acquire very broad and huge, I would say, humongous volumes of stereo images. In that respect, WorldView 1 is doing a great job because it's panchromatic, as you know, can get up to 1 million square kilometers per day and something like 600,000 square kilometers of stereo imaging. There's a number of examples, and Rutgers company knows these images very well, I think, and we are prepared for cooperation. And I know that the company Rutgers approached us, but we have good examples of 30 centimeter stereo data. They're in the internet. You can download them actually and can come and work with us. Another new opportunity that I would like to discuss here is the archive. I told you we have a huge archive. Every day it's increasing by about 4 million square kilometers, and it is also a technological advantage. The data are consistent, mostly, and for different areas as well. Here you can see example of 30 Earth surfaces. Why I'm telling you about this capacities, because all the above mentioned capacities, unfortunately, are not fully used by people, because we can provide a lot of data, but 80% of our data in archive are not used. People have never seen or opened them ever, because archive is growing. It's simply not possible. We need to provide technological possibilities or opportunities for people to get information, and so that customers can get information from those data. How to do this? We developed special platform, geospatial big data. This is like a service platform which allows our users to get access to this huge archives. It is based on supercomputers, and these supercomputers are linked to our archive. They're very close. For instance, if a user needs to know globally what is happening somewhere, our user won't be able to buy this data because it would be too expensive, or get them because it's too long, and to process them. And this platform allows us to order data through internet, a web resource, and then internally this data will be processed and the customer will see the end product. So it's a bit new paradigm that we're talking about here, which allows DG to be not only the operator of satellites, but the source of information. And this platform already has ENVI algorithms. Moreover, it is also open for users to write any algorithm and integrate, so they can integrate them into this platform. And the application of the results can be done jointly.
As for product commercialization, we don't use square kilometers, but rather lease or rent, space rent possibilities, and computing. I am running out of time, so I'll be quick now. There are two stages to use the platform. First off, we provide access, we provide developer access. With this, you cannot commercialize products, but those who does have access can connect to archives, choose data, test algorithms, find flaws, polish their products, and then commercialize it. The second one is production access. This is where a different approach to payment is used. Geo big data is a kind of technological ninjas for our partners. We open access to great archives of data, but also we provide large computing capabilities. At the moment, the platform operates in a stable way with ArcGIS, Hexagon, Envy. I personally added some new possibilities to it and later ran them on supercomputers. For example, we have an algorithm to measure dimensions of buildings, and for the territory of Japan, the platform calculated all the buildings dimensions of Japan in 2 hours and produced a vector file. This is not a final product yet, but these are the capabilities we provide. We spent nearly 2 weeks to select all the images, whilst the computer took 2 hours to measure all buildings' dimensions. Well, the system is almost ready. You could say it's ready. And our partners can be both our customers and users. There is a new process becoming available. We're open for any customer. And within this platform, we are ready to operate in a new way by applying revenue share, where the final product can be commercialized and revenues will be shared with us. Sometimes DG provides images and the rest of the processes are done by the partner. Then we get 30% and the partner receives 70%. But this split can vary and it's always negotiable. GBD production access can be based on subscription, where you pay monthly or annual subscription fee. A few other examples. I tried to use the platform, apply it to Moscow. This is an 8-band multispectral data. I used NDVI and then visualized it. So the platform is stable, operates well. There is a lot of interesting elements in it, So we encourage you to use this platform and to develop new algorithms that can later be commercialized on a global scale. The essence of the model, among other things, is that if you developed an algorithm, we can jointly reap commercial benefits from it. So we can together send the word across that this platform is available, and then we will share revenues. I believe this is all I wanted to share with you for now. Thank you. If you have any questions, please don't hesitate. Огромное спасибо, Илья, за вашу презентацию. Я бы хотел еще раз подчеркнуть усилия, предпринятые компанией DigitalGlobe по повышению доступности архивных данных. Нужно понимать, что это золотая, как золотая шахта, и нужно попытаться выжать из нее все возможное. Большое спасибо за очень интересную презентацию. Завтра состоится круглый стол, посвященный теме спутниковых исследований. Я считаю, что бизнес-модель, которую вы обрисовали, должна обсуждаться в рамках круглого стола. Вопросы коммерциализации очень важны. Мой вопрос связан с технологическими аспектами. У нас есть разрешение в 20 сантиметров, недавно появившееся, и пространственное разрешение определяется не только технологическими аспектами, но и регламентами США. До последнего времени речь шла об ограничении в 50 сантиметров. Таким образом, вопрос, что мы можем ожидать в отношении пространственного разрешения в перспективе? Thank you for your question. There are technical restrictions, technological restrictions, and the best we can expect in the future is 25 centimeters. Anything better than that is nearly impossible because then technological challenges come in. You will either have to change optical sensors or change the sensor or change the orbit of satellite, and this may bring the cost of satellites up or reduce their service life. As for 30 centimeters, it is available. I just wanted to note that there is a little restriction which was imposed by the US government on short-wave infrared data. The original resolution is 3.5 meters, whereas we provide a 7.5 meter resolution. So these are the limitations imposed by the government, and we can't go about it. As for the rest, there are no restrictions. So have they removed the ban from 50 centimeter? It was a long time ago. 30 centimeter is available now for more than 1 year. I have a question too. You know that Skybox company has emerged on the market, and maybe there will be no constellations in place, but DigitalGlobe is moving toward large satellites. GlobeView 4, which is to be launched, is also quite massive in terms of size and weight. But what about DigitalGlobe strategy? Yeah, they talk a lot about microsatellites now, and we have a certain policy and position about it. microsatellites, even though they have great production capabilities, they have not proven their efficiency yet. Because they don't provide accuracy, they don't provide good spatial resolution vis-a-vis large satellite, classical satellite. But of course, we keep it in our sight. We're considering it as well because this creates competition for us. So what's important is that we're trying to move from pixel-based business to product. And this platform is only starting. It was launched earlier this year, and very few people know about it yet. We believe that this platform will be political with regard to sources of data. It could be aerial photography results, Airbus data, Landsat data archive was loaded into it, Deimos data. We are now negotiating with other operators to upload other data in it. And it doesn't matter at the end of the day which satellites are used. And this will reduce competition in a way. But we do believe and we do prefer larger satellites because of better performance features. А будут ли еще вопросы?
Thank you very much.